So this is we're still doing the multiply non-unit. Before it was non-unit with unit. And unit fraction is something that has a numerator of 1. Non-unit is a fraction that has a numerator other than 1. And so now we're doing non-unit to non-unit. Do the steps change? No, it's the same step. It's the same thing. You still multiply straight across. Same thing. Same stuff. Same step. Exactly the same. Just your answers just start to get bigger. Your rectangular model might look a smidge different. The squares start to get a little bit bigger. Okay? So, but the first thing I'm going to do is I'm going to do a little pre-teach of lessons 17 and 18. And all it is taking a fraction and writing it as a decimal. And it's not going to be anything that's really going to blow your mind, so you don't have to do the what face right there. It's okay. So I want you to look at saying this. How do you say that? 2 tenths. 2 tenths. Oh! 2 tenths. If you take a number, because this is like a division, 2 divided by 10, right? 2 divided by 10, 2 divided by 10, 2 divided by 10. Mr. Doll, decimals here, right? I took that sign down, it's gone. 2 divided by 10, decimals here. What happens when you divide? Mr. Doll. Divide. Left. 1 spot, because there's 1 0. 2 tenths. 2 tenths. Decimal only went in 1 spot. 2 tenths. You stop it. I keep getting emails. 5 tenths. Decimal. 5. 5 tenths. 5 divided by 10. 5. Decimal starts here. It goes to the left. 1 spot. That's why it looks like this. 5 tenths. What if I had, let me clear this off. I don't like all this ink. Eight hundredths. That would look like 800ths, because you have an 8, there's a decimal, divide left, 1, 2. This is first quarter. Jaden, do you have a question? I don't know how you can see because Adley keeps getting in the way. Seventeen hundredths. Cheyenne. Well, why throwing the zeros in there? Because if I do this, it's going to the thousands. Because this is tenths, this is hundredths, this is thousands. Because remember, it takes the place value of that very last number. So this one had a 0 because there was only one number. Because when you have 17, the decimal's right here, and it goes 1, 2. So it's decimal 1, 7. Well, it's not that. You don't have to put a 0 in front of it. Do you understand? Ryan? Please put that up. Yes, Shadrach. But I would prefer that you not write on the desk right now because we're about to do some other stuff. How can I do this, the opposite, as a fraction? Can I do that as a fraction? Jaden. 9/100. And so this is where it's very important that you remember your place value from first quarter. Well, you can do that, but it's also just know where it is in the place value. And know that, okay, I've got to go 1, 2 places to put that decimal there. 1, 2 spots. And I need to have 2 right there. 2 zeros. 9/100. So you could think about it either way. That's a good way to think about it. Okay. So moving on to what we are doing today. So, wait a minute, let me go back. If I have that Kendra spent 1/3 of her allowance on a book, and 2/5 on a snack. If she had $4, key word right here, remaining. If she had $4 remaining, after purchasing a book and snack, I'm just going to put them. I don't want to write all that. After purchasing a book and snack, what was the total what was the total amount of her allowance? So it's almost asking what did she start with. So we almost need to do like a working backwards kind of thing. So we need to know the total that she had to begin with. So is this something that I can do with a number, multiply kind of deal? No. I need to do a tape diagram. And this is where I was telling you that even though you may not be comfortable with doing them, you need to learn how to do them. And this is why I keep posting these videos. This is why I want you to keep going back and referencing the videos, because when you go home, you forget how to do this stuff. But I know that some of you are not doing it, and it's very obvious. So, if I have a tape diagram, I know that she bought a book, because 1/3 of her allowance was on a book and 2/5 was on a snack. So I can do 1/3 was a book. Okay. Y'all gonna hate me. Let me erase this one little bit. Because when you have these two different units, I was trying to look at it. Okay. Where I have that I have 1/3 of her allowance and 2/5 on a snack. If she had $4 remaining. So one thing is I don't know what her total amount is. That's what I need to figure out. Now, what I'm trying to figure out right here is how am I going to split up my tape diagram? How can I separate that into parts? How can I separate that into pieces to where it can make some kind of sense? What can I do with it? Yes, ma'am. Okay, well, I could do it in fifths, but how would that help me with thirds? See, so that wouldn't really help me there. Okay, so what can I do here? 15ths, because that's a common denominator. So it's really hard to put it in 15. So let me try. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 15. 11, 12, 13, 14, 15. That's a really big piece on the end. Ugh, yuck. Make it a little bit smaller. My pieces have to be matchy. I know. Okay. Now it's all symmetrical. I know. Okay. So now we've got 15 to where they equal out. To where I can do thirds and I can do fifths. So now I need to make them equivalent fractions. Okay? I'm going to do red. It all bleeds in together. So, because I know y'all can't see, I'm going to write it up here. 1/3 is equal to, if I do 15ths, 5/15. So 1, 2, 3, 4, 5. This much of her allowance was spent on a book. Does that make more sense now? I had to stare at it for a second. 2/5. We're doing 15ths. 6/15 was on a snack. I like color coding. 1, 2, 3, 4, 5, 6. Snack. It must have been an expensive snack. It was more than a book. Or a very cheap book because, books were expensive. Okay. If she had $4 remaining after purchasing them, what was the total amount of her allowance? So this ends up being 4/15. This is 4 units, 2, 3, 4. 4 out of 14, and each unit equals
like 9 spaces left after I supposed to.
Oh my goodness gracious. So if she has $4 remaining, and this is 1, 2, 3, 4 out of 15. 4 units equals 4. Because she has $4 left. 1, 2, 3, 4 units equals 4. 4 equals 4. So each unit equals
$1.
$1. So if this one equals 1, and that one equals 1, and 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 1. So what was the total amount of her allowance? $15.
Okay, now I got it right. I think I did a little way too many things.
We're doing math, silly head.
Oh, I thought it was
This is like science up here. So, now, as I told you, the only difference between this lesson and the other lesson is that we went from a unit fraction to a non-unit fraction. That's really the only difference that I see. So, the first one is done for you, where they went from 2/3 of 3/5. So, I'm going to redo A, so you can see how they got it. So I need everyone looking up here and not looking anywhere else. Not looking at your fingers, not looking at a pencil, not looking at a desk, not looking anywhere else but looking up here. Okay. So we have 2/3 of 3/5. So on the rectangular model, I don't really see the need to put this 1 up here. It's just an extra bracket to do. Obviously, you've got the whole thing. Obviously, you've got 1. Why write it? That's just an extra thing to do. I don't see the need. So for 3/5, I'm going to draw out my fifths, 2, 3, 4, and 5. And so I've got 3 of them. So I'm shading in 3. So this whole thing is 3/5. So there's the 3/5. I'm just drawing what's already been drawn. I'm just like, hello, here it is. So this is the 3/5. So we're doing 2/3 of the 3/5. So I'm going to go thirds going the opposite direction. So there's 1, and 2. That's so crooked. I'm going to try not to let that bother me. So I've got to do 2/3, because before we would do a unit fraction of that. We would just do 1. Now we're going to do 2 because it's telling me to. So put the dry erase marker away. So I'm going to color in 1 and 2. 2/3. So now my denominator is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 total pieces. And then they want to know, come on, how many are double shaded? 1, 2, 3, 4, 5, 6.
Oh, that's how you do it?
That's how you do it. That's why you don't go to sleep during math. So then here, and then of course that can be simplified. Here, when it's 2/3 times 3/5, you multiply straight across. 2 times 3, 6. 3 times 5, 15. Do they share a factor? Do they have a number that can go into both?
That's 3.
3. 3 can go into 6, 3 can go into 15. So I divide the top and the bottom. What you do to the top, you have to do to the bottom. You don't do a different number. You don't say, oh, 2 can go into 6, but 3 can go into 15. It has to be the same number. What you do to the top, you have to do to the bottom. 6 divided by 3 is 2. 15 divided by 3 is 5. 2/5. That's how they got that on A. And you would need to simplify that over there. I just didn't. Any questions? So I have video proof that they just said no.
No.
Okay.
Yeah.
So, what?
If you don't get the picture, can you just
I want you to practice doing the picture just because it's good practice to have. The picture just backs up the math. It's not always going to ask you to do the picture, it's just good practice. Because sometimes, like with the tape diagram, there is no math. Like on that tape diagram we just did, sometimes there is no math. You just have to be able to draw it out and figure it out. So sometimes you have to be able to do a picture to back up the math, to figure it out. See what I'm saying? So sometimes you just need to be able to do
So that's
a diagram. Ma'am. Uh-huh. So, well, what I've done before is off to the side, I would look and see what numbers can multiply to make 6. So, like, in your case, because sometimes I know that you might struggle trying to find numbers that would make that, and I'm not making fun or poking or anything like that. I'll say, okay, what numbers can multiply together? So I know that some of you would struggle simplifying. What numbers can multiply together to make 6? So maybe off to the side, write 6. Well, I know that 1 times 6. I know that 2 times 3. And a lot of times when you get to where the numbers are right beside each other, that's it. There is no 4, there is no 5, and then there's 6. And so, but the same thing with 15. I know that 1 and 15. 2, no. 3. 3 times 5. 4, no. And then there's 5. That's it. So then I go at my list. There's nothing wrong with making a list. You don't have to store it up here. So with here, then I look and see if there's a match. 1 is just 1. I see, okay, here's 3. There's 3. Simplify by 3. So write it out. There's nothing wrong with writing it out. Okay? Yes, no, maybe?
Yeah.
You see what I did? Okay. So go ahead and try to do B. So 3/4 of 4/5. So you've got the rectangular model. 1, 2, 3, 4. So you got 5 sections, coloring in 4 of them. So that's 4/5. I'm taking 3/4 of it. So 1, 2, 3, 4. We're going to color in 3 of them. 1, 2, 3. So 3/4. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 total pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of the 20 should be colored in.
Okay.
So I can easily tell that that can be simplified because they're both even, 12 and 20. So they should be able to be at least simplified by 2. But I know that they can be simplified by 4. I know. I was just telling you I know they can be simplified by 2 because they're even. So that's 3/5. But 3/4 times 4/5. 3 times 4 is 12. 4 times 5 is 20. And again, we know that that's really 3/5. So I want you to do C, D, and E.
Yes.
2/5 of 2/3. So put this in thirds. Color in 2. Two fifths. 1, 2, 3, 4. Color in 2 of them. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 4 of them are colored in. So my answer should be 4/15. 2/5 times 2/3. 2 times 2 equals 4. 5 times 3 equals 15. Well, if I think about my factors, 1 times 4 and 2 times 2, none of those go into 15. So that's as low as it can go. 4/5 of 2/3. There's 2/3. So 1, 2, 3, 4. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces. And 1, 2, 3, 4, 5, 6, 7, 8 of them are colored in. So with 8, 1 and 8, 2 and 4, none of those will go into 15. That's as small as it goes. So 4/5 times 2/3. 4 times 2 is 8. 5 times 3 is 15. That's as low as it goes. Can't do any different. 2/3. 3/4. There's 4 of them. Color in 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. 6/12. Well,
Oh, I only simplified by 2.
well, if I did that, I can. 6 divided by 2 would leave me with 3, and 12 divided by 2 would leave me with 6. 3, 6. And then I would be stuck having to do that by 3, and it'd be 1/2. You're not done. You're not wrong doing it by 2. You're just not done. You have to do it again. If you do it by 2, you'd have to do it again. If you do it by 3, you have to do it again. So if you did your list of what can go into 6, 1 times 6, 2 times 3, and that would be it. If you did 12, 1 times 12, 2 times 6, 3 times 4, and you try to find the numbers that they match up, 3 and 3, 6 and 6, 2 and 2, might as well go for the biggest one. The biggest one would be 6. That way you don't have to simplify more than once. Try to find the biggest factor. 3 times 4, 3 times 4, 3/4 times 2/3. 3 times 2 is 6, 4 times 3 is 12, same thing. If I simply go ahead and simplify by 6, I'm done. 1/2. Rather than having to simplify twice. So here, they're not telling you to do a rectangular fraction model. They just said if it helps you. Here, they're doing the simplify within the problem. So here, they're doing the 3/4 times 5, 6. With 3 times 5, they're mushing them together. 4 times 6, they're putting them together. Adlin, I'm over here. So what we're doing here, I'm going to go ahead and look at this problem that they've already done. 6/7 times 5/8. 6 times 5 over 7 times 8. So what they're doing is going ahead and simplifying in the problem. I can look at my 6 and my 8. And kind of like up here where I'm simplifying, you don't have to do this. But if you look and see and go, oh, there's a number that can go into both. Like 2. So 2 can go into 6. How many times? 3. 2 can go into 8. 4 times. So then you're already simplifying your fraction. 3 times 5 is 15. 7 times 4 is 28. You don't have to do this. If that's too much for you to consider, don't do it. Just go ahead and multiply it and simplify it when you're done. This is just simplifying to go ahead and make your numbers smaller. So while you're looking at this, 3 times 5 equals 4 times 6. They're in that second drawer. So while I'm looking at 3 times 5, 4 times 6, with the top comparing the bottom, do you see anything where they might share a factor, like if you were simplifying fractions? 3 and 6. My 3 has something in common with my 6. Now, they don't share a 2, because 3 can't have a 2. But 3, what? 3 can go into 6. 3 becomes a 1. 6 becomes a 2. For the top and the bottom can both be simplified by 3 before you multiply anything. So 1 times 5 is 5. 4 times 2 is 8. That way you're not stuck with 15 over 24, which is not wrong. But you're stuck having to simplify it later by 3. You can do it either way. You don't have to do this. Okay? But you still have to have your fractions simplified at the end of the day. So 4/5. So you mush them together. 5/8. Do you see something? I see a whole lot of something I can do here.
4.
So I can mess with the 4 and the 8.
Oh, and the
So the 4 and the 8 can both be affected by 4. So I can divide the top and the bottom by 4. So the 4 will be canceled out, will become a 1. The 8 will become a 2. What about these guys right here?
they both can be they're both 5.
They're both 5s, and so they can both become
1.
the top and the bottom. If I have 5/5, or, they can both, the top and the bottom can both be divided by
1. 5.
5. So 5 can go into 5, and you get
1.
1.
It's not 5 times 5.
No, 5 plus 5. So, but I mean, if you look at it, if you just went ahead and multiplied it, and because you're still looking at me, you're going, I have no idea what you just did. Okay? So I just multiply it. What's 4 times 5? 20.
And
What's 5 times 8? 40. I had 20 over 40. What do you get with 20 over 40? One.
Oh, 1/2. 1/2. 1/2. I said it first.
I don't care who says it first. I just want you to say it right. So you still get the same answer. So if you still look at this like I have no idea what you did, all I did was look at 4. Sit down. Sit down. What? Right here or right here? With this one? Because 20 can go into 20 one time. 20 can go into 40 two times. What?
Because one
It looks easier when you got a
Okay.
fraction bottle.
See, I can, if I really want to, I'm going to go by 5. 20 divided by 5 is 4. 20 divided by 40 divided by 5 would be 8. 4 eighths. 4 eighths, not 5 eighths. 4 eighths. And it would still be 1/2. So, but see, I don't mind you asking questions. When you ask questions, either I realize that I have made a mistake, or you realize that you made a mistake. Either way, someone made a mistake. Or we just kind of realize, oh, that's how you do it. So that's okay. I appreciate when you ask questions. That's the whole point. So with, when you've got this multiplying, you don't have to simplify within the problem if you don't get it. It just makes it to where you're not having to deal with such big numbers. If you don't get it, don't do it. If you do get it, do it. Just do it right. That's the only thing. So, here we notice that the 4 and the 8 had a factor in common. And it was 4. You could do 2, but 4 is better. 4 divided by 4 was 1. 8 divided by 4 was 2. 5 and 5 had a factor in common, and it was 5. 5 divided by 5 was 1. 5 divided by 5 was 1. What you do to the top, you have to do to the bottom. And then you go ahead and multiply. 1 times 1 is 1. 1 times 2 is 2. And if you still are just like, I don't get it, pull up the video when you get home. That's why I do it. Goodness gracious.
When you discovered that last thing now, the green stuff.
The green. What have you been doing the whole time?
No, I was washing my hands because I was licking my hands when I was eating my stuff. So I have to wash
Okay. 2/3 times 6/7. So, first thing you're going to do is you're going to mush them together. Now, when you do the simplify, you don't simplify on the same level. Like 2 and 6. Yes, I know they have something in common, but they're on the same level. So you can't mess with those. It has to be a top and bottom thing. But 6 and 3, good eye. 6 and 3. Now, can I just go ahead and multiply and leave it be? Yes.
No, wait.
I can, but then I'm stuck having to simplify. So, and I hate simplifying first. So, these have a 3 in common. So, I'm going to mess with these. I don't have to if I don't want to. 3 divided by 3 is 1. 6 divided by 3 is 6 divided by 3 is 2. So now I can multiply. 2 times 2 is 4. 1 times 7 is 7. So now I've got 4 7s. And I don't have to simplify now. We already did it. Oh! Because if you went ahead and did it, you would get 12 over 21. And you may not realize that you can simplify. Oh, well, I know. But it's such an ugly fraction, you may not notice it. See what I'm saying? Because it's such an ugly fraction.
I got
Yes.
is that a minus sign or an equal sign?
4 times 3, did you hear me say subtract at any point in this problem? Times 9 tenths. Do you see anything in this problem where we can simplify within? What? So with the 3 and the 9, we can do something to those. 3 and 9. So 3 and 9. So what can I do to the 3? I can divide it by 3 and I'll get 1. What happens to the 9? Becomes a 3. Can I do anything to the 4 and the 10?
Nope.
I can. I can divide it by 2. 4 and 10, they can both be divided by 2. They share a factor of 2. They did. So 4 divided by 2 is 2. 10 divided by 2 is 5. So now I've got 2 times 1 is 2. 3 times 5 is 15. Now I don't have to simplify at all.
So this is like a shortcut.
It's a shortcut to simplifying. Because if I had left this alone, I would have had 4 30ths, and you would have had to simplify by 2. But now you don't have to because you already did it.
Yeah, that's what I did.
That's what I'm wondering recording.
Because
Okay. We've got a few more minutes. So let's look at the word problems. And you're like, let's not. Okay. But we need to.
she's on.
Looks like you're giving me a stink eye there for a minute.
Oh no, I actually got it. It was by accident.
Alright. So, Philip's family traveled 3/10 of the distance to his grandmother's house on Saturday. They traveled 4/7 of the remaining distance on Sunday. What fraction of the total distance to his grandmother's house was traveled on Sunday? Now, I can tell you that this is not a number multiply problem. This is a tape diagram problem. Which is, I don't like those problems. You need to be able to read the problem. Whenever you hear like a remaining kind of thing, you need to realize that's probably going to be a tape diagram type problem. So, let's see. So we have a tape diagram. So we know the top portion is going to be the total distance. That's what we need to know. I mean, every time you've got a tape diagram kind of thing, the top is going to be the total. So that's the whole thing. The top is the total distance that we don't know. That's the unknown. The total. Please tell me you're going to carry on a conversation right there, because then I can fuss at you. Oh, this is recording. That'd be fine. So, how many pieces is my tape diagram going to need? 10. Because they traveled 3/10 of the distance on Saturday. So it's going to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Please tell me you're writing some part of this down. So I already know that I can put this 3/10, that this is Saturday. That 3 out of the 10 was Saturday. I got way more than you written down. Come on, buddy. I'm old, my hands are all old lady looking, your hands are young and vibrant. Y'all can write down faster than I can, and I'm writing faster than you. Quit worrying about making it look like a cube. Let's go.
Cube.
Okay, so it says they traveled 4/7 of the remaining distance on Sunday. Now, why is it that they're saying 4/7?
Because they're
Because they already did 3, and
and
10 minus 3 is 7. There are only 7 pieces left. So 4/7 of the remaining.
so don't
So 4/7 of the remaining distance on Sunday. So 1, 2, 3, 4 Sunday. Oh my goodness, we've almost time already. Oh, curses.
time for what?
Okay, so what is the actual fraction? What would we actually really call the fraction of this distance that was traveled on Sunday? What would we really call it? It's not really 4/7. What would we call it?
4/10.
4/10. Because each piece is a tenth. Very good.